students, welcome back. Today I'll go with physics session. I promised you in electricity that I'll go with numericals section. Now today numericals of electricity will be done. So sit with your register and note down all the formulas which I'll give right now, and then we will go with numericals. Yes student, ready? Okay, come. Now first we'll start with the formulas. Now first formula is the number of electron. How will we find the number of electron? That is N is equal to charge upon electron, and the electronic charge is 1.6 into 10 to the power 19 coulomb. Am I right? 10 to the power minus 19 coulomb. Minus 19 coulomb. Clear? Next come. So if we crisscross, then Q is equal to, if we want to find the charge, then N into E. N into E. Clear? Now next is I. What is current? It is the charge flowing in 1 second. So Q upon T. So Q is equal to I into T. Clear? Third, potential difference. It is the amount of work done to carry the charge. That is, work done is equal to Q. So W is equal to VQ. Clear? Right? All I have taught you in my sessions, physics sessions. Now fourth, it was Ohm's law. That is, V is equal to IR. So I is equal to V upon R. Correct? The magical formula. Very, very important. Yes. Next is 5. Series parallel. If RS is equal to R1 plus R2 plus R3 and so many resistors. 1 upon Rp, that is resistance in parallel, 1 upon R plus 1 upon R2 plus so many. Clear? Now next formula is what was it? Power. So no, R is equal to rho L by A. This is again with the resistivity, the relation between the resistance, resistivity, length and area. Right? This is one formula. Next formula is power. P is equal to VI. 3 formulas we have derived in power. P is equal to V square upon R and P is equal to I square R. Right? Next is, I'm rubbing this. Yes. Next is number 8. E is equal to energy. P is equal to W upon T. So work done is equal to electrical energy. So E is equal to P into T. This is 8th, 9th, 10th formula. 10th formula. Next, 11th formula. Heat is equal to VQ. That is V into Q. Q is equal to IT, or if the in numerical INT is given, then also you can use this formula VIT or IT into VQ. So we can use this formula. And H is equal to I square RT. That is time given multiplied by month and rate of electricity. Rate. H is equal to I square RT. Rate at which the electricity is consumed. Right? So these are the formulas which are very, very important for your electricity chapter. These formulas, if you are holding it in your mind, then it will be very easy to calculate the numericals. Now next, let us start with numericals. Suppose for example, if I say, if 12 volt battery, clear? Now first, always important student, you will write the breakups first. Then it will be easier for you to put the formula. If you try it direct, you will use that formula, then it is not possible. If you write all the breakups, then it will be easier for you. This is very easy to attempt the numerical. And if we say V given is, V is 12 volt battery, 12 volt battery to connected to unknown resistance. That means we don't know the resistance. See, this is how we'll write it. We don't know the resistance because it is the unknown resistance. Flowing the current is 2.5 milliampere. Milliampere. What is the meaning of milli? Into 10 to the power minus 3 ampere. So 2.5 into 10 to the power minus 3 ampere. Minus 3 ampere. This is milliampere. We will open this formula. Clear? Units will what? Simplify the unit. Next is, if I say find R, which formula we'll use? Ohm's law. We know that R is equal to V upon I. Very easy. So, what will be the answer? And V given is 12 volts. So, 2.5, 12 volt given. So, 12 upon 2.5 into 10 to the power minus 3 ampere. This will be 4800, or you can say 4.8 if you solve this into 10 to the power minus 3 ohm. Or you can call 10 to the power minus 3 is kilo. So 4.8 kilo ohm. These are all specifying or simplifying the units. So this is all. See, nothing is there in this numerical. Simply you put the formula, you will use all this units and all. Clear? Now next numerical. Next numerical. Come. Now 2 lamps were given. 2 lamps. This is question number 12. 2 lamps were given rated. Now rated means the power given. Right? Rated. Now 2 lamps. First lamp, if I am talking about first lamp. So power given is 100 watt. And volt given is 220 volt. And this is for first lamp. P2 for second lamp. We given 220 volt. 220 volt. Clear, students? Now find the total current. Find the total current. This is how you will ready with your numerical. Now formula we all know. What? P is equal to VI. So I is equal to P upon V. So first you find what? I1, that is power given 100 upon 220. Clear? Next you find I2, that is P2 upon V. This is P1. See, volt is common because it is domestic. And always, whenever we are using any domestic appliance, we'll always use 220 volt. Clear? And always in parallel. So they are connected in parallel. Now, when we find the current, then what is the total current you will find? I1 plus I2. Done. And you will get in ampere. Clear? So this is how, these are all from NCERT. From your book only. These are the type of questions and examples were there in your book. Right? Next. Now suppose if I am talking about any resistance. Resistance and series and parallel. Suppose this is the example given. Wait. I'm rubbing all this question. Now, suppose this is the example given. Here. This, and suppose this is the circuit, and this is one resistance. This is one resistance connected, and from here, this is the switch. This is the battery, positive, going from this side, positive to negative, positive, negative, and this is how. Clear? And suppose if I arrange ammeter over here to find the current. Clear? This is R1, R2, R3 and R4. All the resistances are of 10 ohm each. 10 ohm, 10 ohm, 10 ohm and 10 ohm. Now, this is in front of your exam. Suppose if it comes in your question paper in board, you will just simply seeing it and you get worried about. Very easy, nothing to do. First we have to open this circuit. Open this circuit. Now I told you series are always connected end to end. End to end. See, end to end. End to end. That means this portion is in series. If I open this, what will be? 1, 2, 3. See, this is, I have opened this wire. This is how I have simplified this. And this is R1, R2, R3. Correct? 10, 10 and 10. First I'll open this. This is how only it is bent, the shape has been given. If I open this, I can do it like this. The shape of the wire can be drawn in straight line. Right? So, nothing to worry about. First, you will check it out which is end-to-end connection. These are all end-to-end connection, and from here, this end and this end, this much is there, that's it. And this is from this circuit. This is one circuit from here to here, and this is being connected to this. That means these three series, first we'll find RS. Means these are all connected in series. 10 plus 10 plus 10. That is 30 ohm. Clear, students? See? And now these three resistors which are in series are connected with parallel to R4. This is R5, R2, R1, R2, R3 and R4. So, this is parallel. Then what will we do? We'll find RP. RP 1 by 10 plus 1 by 30. Nothing is there. Yes? Always will simplify. Will always simplify the diagram. Okay, which is end to end? Now these are all end to end in series, but this portion and this portion is in parallel because the wire is connected over here. This is how you will find. And then you will find the LCM. What will be the answer then? You will check it out and find the ammeter reading. That means they are asking about current. Ammeter reading means ammeter measures the current. So find the ammeter. So we know that by Ohm's law, I is equal to V by R. Once you find the R, you can easily find the volt given is 6 volt. So 6 upon, you find the answer, you will get. Clear? Next one. Suppose if I say this diagram. This is starting point and 1, 2 and here again 3, 4. See? Clear? And this is, right student? And this is the what? Circuit diagram. This is how the circuit is connected. Now this is 3 ohm, 3 ohm, 4 ohm, 4 ohm and 1 ohm. Now again find the resistance and current. What we will do? We'll just open the wire. Simplify this wire. This is one wire connected. This is one wire connected. Suppose R1, R2, R3, R4, R5. Clear? So, 1, 2, 3, 4. This and this first we will open this. Right? This is the same wire. See student, this is the same wire. This is the same wire. So, first we will find the series. Suppose if I say RS is equal to R1 plus R2. This one. Clear? So if I open this, what will happen? This and this. See. Clear? This is one RS series, that is 3 plus 3, 6 ohm. Right student? Now we'll find this series. We'll open it again. Open this. 3 and 3 ohm, 6 ohm. Now again this is in series. This is in series. But this is 4 ohm. And this is 4 ohm. This 4 ohm. Clear? So, when I am opening this wire, when I am simplifying this portion, then it will be R dash series. R dash series, that is 4 plus 4 is equal to 8 ohm. Right student? Now, This wire simplified. This wire simplified. RS, R dash S, RP, and these are all in parallel to each other. These are all parallel. This wire is coming parallel to this wire. This wire is coming parallel to this wire. So what will be 1 upon RP? 1 upon RP plus 1 upon RS, that is this series, plus 1 upon R dash S. Very easy. So what will be then? 1 upon RP is 1 upon 1 plus 1 upon 3 plus 3, 6 plus 1 upon 8. And you will find, now if 1 upon RP, whatever the answer, then RP is equal to, reciprocate it and you will get total R. Clear, student? So don't worry at all. Always you will simplify the wire. You will open this wire like this. This is just has been bent over there. So this and this, you will check it out, end to end, end to end. So this is one portion, this is one portion, and these are connected parallel to the center point. Clear? So don't worry at all ki numerical is there. Oh my God, what I don't know, I can't help it out. No, very easy. So this is how you can go with the numericals. Now next question. Come. Suppose if I say the next question is what? First resistance, second resistance, again parallel to each other. This is again, and see, seems to be so tough. Seems to be so tough. This is the battery, negative, and this is your switch. Clear? All 2 ohm. Suppose you all 2 ohm, 2 ohm, 2 ohm, 4 ohm and 3 ohm. Now what you will do? Simplify this now. And this is of 6 volt. Find the total resistance. First, we will go with this. We will go with this. Then we will connect in series. So, 1 by RP, 1 by RP, clear, is equal to 1 by 2 plus 1 by 2. Find the answer. Next, 1 by RP dash. Why RP dash? This is again with the second parallel. What? The set of second parallel, the set of first parallel. Again, 1 by 2 plus 1 by 2. You find the answer. Now, these two are in the same wire, that is in series. So, the answer will all come in series, that is, this is also in series, this is. So, 4 plus RP plus RP dash, RP plus 3. And you get the total resistance in ohm. Can you able to solve this? Clear? Next is, if what is the current total? I is equal to V by R. There is 6 volt given upon R. Ready? Yes? Please go for all this. The more and more practice, you can frame these numericals yourself. Any shape you can draw and you can get it. Just first thing you always keep in mind, we have to simplify this all sets given. Right? Next. These are all series parallel numerical. Now next is this question, let us go with. Judge the equivalent resistance in parallel. Now this is question number 3. Judge the equivalent resistance in parallel, which is 1 ohm. R is equal to 1 ohm, 10 to the power 3 and 10 to the power 6 ohm. Yes. Now they are all connected in parallel. RP is there in parallel. What we will do? 1 by RP connected in parallel, 1 by 1 plus 1 by 10 to the power 3 plus 1 by 10 to the power 6. Very easy. Nothing is there in this numerical. This may come for 2 or 1 marks. Now what we will do when we are reciprocal? Suppose if I say RP is equal to 1 plus, reciprocate this, 10 to the power minus 3 plus 10 to the power minus 6. Clear, student? Now what is this? Minus 3 and minus 6 are so small that the resistance is counted to be negligible, because 10 to the power minus 3 resistance, it is not negligible, it is totally negligible, because in the circuit it is of no use. So what you will write? 10 to the power minus 3 and 10 to the power minus 6 R is negligible. That means considered to be 0. Considered to be 0. So 1 plus 0 plus 0. This is Rp. So Rp is equal to 1 ohm. Clear, student? So always they are connected in parallel and you have to judge the resistance, equivalent resistance. If they are not connected in parallel, then it is possible. Then this case will not be there. It is whenever you are judging the equivalent resistance in parallel, that means you have to show like this. Suppose here it is 10 to the power minus 9 and 10 to the power 6. Then 1 upon 1 plus 1 upon 10 to the power 6, 10 to the power 9. So reciprocated minus, it is quite negligible. The R is so small that it is considered to be negligible, which can't be used in any of the circuit. So we'll consider it as 0 and always the answer will be 1. Because the clue of 1 has to be given, you will find that 1 is there in the numerical. So that R, if it is 1 is not there, then the 0 only. 0. Right? Next numerical come. This is how the pattern of numericals are there in your book. Next numerical is very, very important. That is hit and trial method. It is here. Question number 5. If R given 2 ohm, 3 ohm and 6 ohm. How you will connect this? How these R's can be connected to give 4 ohm and 1 ohm resistance? See, answer has been given. And these are the 3. How you will connect these resistances so that you will get this answer and this answer? Hit and trial method. Hit and trial method. Now what are the possibilities of connecting? First, we can connect in series. We can connect it in series. You find the answer? If it is not coming, the second option, connect in parallel. Connect in parallel. In parallel. Clear? This is another case. RP. Next is 1 series and 2 in parallel. 1 series, 2 in parallel. This is another possibility. First possibility, second possibility, first is in series, second is RP, RS, 1 RS, 2 RP. Right? And next is what? What is the fourth possibility? 2 in series and 1 in parallel. These are the only 4 possibilities which can be possible to connect the resistances in your syllabus. Right? So, to get this answer, I am talking about these possibilities. If the answer is given here. Now, 4 ohm, 1 ohm. Hit and trial. First series, nothing to do. 3 plus 2, what? 3, 5 plus 6, 11. Answer is not 11. So, not possible. Not possible. RP we can check. We will check with RP. That is, suppose if I say 1 upon RP is equal to 1 upon 2 plus 1 upon 3 plus 1 upon 6. So, what will be then? What will be the answer with parallel? I think answer will not come with this. 1 by 3 plus 2 plus upon 6. So 3, 4, 5, 6 upon 6. Yes, it is 1 ohm. That means in parallel the 1 ohm answer is possible. So possibility of parallel connection is there. So one answer we got. Now hit and trial. Next, these two are not possible. Let's try with the third one. So if I say R1, R2 and R3. First, obviously I'll simplify this one. So 1 upon Rp is equal to 1 upon 3, that is 3 ohm, and 6 ohm is there, given. It is given here, and this is 2 ohm. Clear? So 1 upon 3 plus 1 upon 6. So it will be, what will be the answer? 2 plus 1 upon 6 gives 3 by 6, 2. So this is 1 upon RP came. So RP is equal to 2 by 1, that is 2 ohm. Yes. Now this portion is 2 ohm. And 2 plus 2. Yes, student. R, that is 2 plus series 2 ohm is equal to 4 ohm. Here's the answer. We'll not try this. Clear? This type of numericals will come for 2 marks in your board. In your board, it will come for 2 marks. So only in rough you will do this. Hit and try. Then finally, when you are writing answer in your sheet, then you will write only those 2 possibilities and show the diagram. But don't show all this in your present sheet, which you are presenting in that. Rough sheet you will use for this. So what are the 4 possibilities to solve this kind of numerical? First in series, second in parallel, third in series, 2 parallel, 2 series, 1 parallel. Right? So this is another type of numerical. These are all different patterns of numerical are there in your NCERT book. Now, next is calculate the number of electron. This is again in your NCERT. Calculate the number of electron means N is equal to Q upon E. Q upon E, the Q given 1 charge. So 1 upon 1.6 into 10 to the power minus 19 coulomb. And you can find it out. Right? Direct formula is there. Next come question. If R is constant, very easy, very important again. If R kept constant, suppose R is constant and V is decreasing to half. V is decreasing to half. That means V is equal to V upon 2. What is the new V? First V and then this is V dash, that is V upon 2. Then what is the current? What will be the current? We know that V is equal to IR. So I is equal to V upon R and V here given half. V decreased to half. Then V upon 2 upon R. Then what will be it? V upon 2R. And we know that V upon R is equal to I. So 2 V upon R, that is I upon 2. I will also become half because V is equal to IR. V is directly proportional to current. So if V is halved, I is also halved. This is how you will prove it. Nothing is there. Right? This is again from NCERT question only. Next come. This has been done, this done, this done. An electric lamp of, suppose if I say the electric lamp, first case, lamp given question. Electric lamp of 100 ohm are given 100 ohm. Toaster, if I am talking about toaster are given, what is given? 50 ohm. 50 ohm. Filter, electrical water filter. Electrical water filter given. Water filter is given 500 ohm. And they are all connected in parallel. Why parallel, student? Again, these are domestic appliances. So they are, if it is not mentioned in the numerical, it will mention. But if it is not mentioned, you will write in parallel. Because all the domestic appliances are connected in parallel. So more, if the parallel is there, less is the resistance and more is the current. So always these are all appliances which are there in the household activities, that is always in parallel. So first, what they are asking? What is total R? So R, that means they are all connected in parallel. So 1 by RP is equal to 1 by 100 plus 1 by 50 plus 1 upon 500. So what is the LCM then? 500 and 5 plus 10 plus 1. So it will be 16 upon 500. 16 upon 500. This is 1 upon RP. Then RP is equal to, we will always, don't forget to reciprocate, because here we are finding RP. This is 1 upon RP came. So if we are reciprocating, then it will be 16. And the answer will be almost 31.25 ohm. This is the resistance came. Now the question continues again. If we add electric iron to the same source, that means battery same, then what will be the resistance? Then what will we do, student? Find current. They are asking if they are connecting to the same source, taking the same current also, then what will be the current finally? So what we will do next? We know that it is connecting, so here R is equal to RP, because source is same. Then the electric iron is again what is the source then? And if it is same, then answer will also 31.25 ohm. 31.25 ohm, because it is connected to the same source, right? Now what is then current of this? Electric current. They are asking of the iron electric current. We know that I is equal to V upon R. So V is equal to what? How much V is given here? It is given 7.04. 7.04 is given. The volt given 220 volt. So V is equal to, if it is 220 volt, first we have to find the current of this. Then we have to find the ampere. Clear? So 220 upon, if we are finding these three appliances we are talking about, then it is 31.25. We are finding current of this, but these three, not iron here. No iron here. Now the answer will be, current will be 7.04 ampere will come. Yes. Now see what I have explained. Very, very easy. Student, first we are finding all these three appliances. When we are connecting this iron in the same source, then, and they are saying this is 220 volt only and R is not given. So what will be? It will all same, whatever the R coming here, whatever the volt is coming here, to the same source we have applied this. We have not changed any voltage or resistance. Then what will happen? The same current will flow through iron only. Right? Because R is equal to RP. R is equal to RP, which is equal to 31.25. 31.25. So V upon R, this is iron, and the total current. Now the total current of all four. So total current of all four, that is including iron, volt 220 volt and 31.25. This is the total ampere came. Yes? Correct? So don't confuse. If they have given, and they will also give also that the fourth appliances is connected to the same source. That's it. They are not. If they are giving R or some volt is different, then there is another procedure. Then you will first find the iron, then you will add it up to this. Correct? Otherwise, it will be the same source. Everything will same. Finally, the total current will come. Right? Next numerical come. Suppose, how can the resistance can be connected? They have given question 2 ohm, 4 ohm, 6 ohm and 24 ohm. 4 resistances has been given. Find the lowest value and the highest value of resistance. Now lowest value, parallel only. So first you find, don't write this lowest is in parallel and highest in series. No, you have to show. First you will add it up, then you will find series, and then you will find RP. Then you will show that this is highest and this is lowest. Highest, why highest? Add it up and show with the formula, and lowest, show it in parallel connection. Yes? Okay? Come, next one. This is another pattern. These are all different types of patterns are there. Highest and lowest. Next is compute the heat generated while transferring 9600 charge. That means Q given 9600 again from NCERT only. Charge, that is coulomb, 9600 coulomb charge in 1 hour. T given 1 hour. T given 1 hour and V is 50 volt. V given 50 volt. So what we have to find? Heat generated. Heat. Yes. What you will do? 60 to 60 second. Why? Why we are converting into second? Because this is in volt. Volt is in which the work done is in joule. That is why we are using second over. Either you will use H is equal to VIT. I have already told you in the formula. This is the direct. This is V is given. Oh, I is not given. I is not given. Then what you will do? We know that H is equal to I into T is Q. So Q is given, student. Q is given. So this is another formula. VQ. So 50 into 9600. What will be the answer then? 6 5s are 30, 9 5s are, then it is almost 48. 96 into 5, 48,000. 6 zeros will be there. Clear? After this, right? So 48, 1, 2, 3, 4, 5, 6. So we have to simplify this unit. Then we will write 4.8 into 10 to the power 1, 2, 3, 4, 5, 6. Point we have here. So 6. And what will be the this thing? What? We are finding heat. Heat is in joule. Heat we are finding in joule. Clear? So this is how it can be done. Joule. Yes. Clear, student? This is how this. Don't confuse it with VIT. If I is not given, what? Q is given. And R, it is understood, that is coulomb, and volt, that is in joule. Answer is in joule. Nothing to do with this T. Nothing to do with this T. Okay? So this is just for confusion they used to give. Next come, what is the question? If R given this, yes. Come, another question. If R given is 20 ohm, and I given 5 ampere, and T given 30 seconds. T given 30 seconds. Find or compute heat. Yes, nothing. H is equal to which formula, students? Which formula? I square, Joule's law of heating. This is I square RT. So, I, that is 5 square into 20 into 30. If day is given, suppose day is given for the month of November. November we know that there are 30 days. So we'll multiply with 30. So heat generated for 30 days. That is, heat may be generating from the geyser or electric heater, whatever. We can find it in 30 days. What will be the answer and how much amount of heat is generated. Right? Next, any other? Yes, electric motor takes, this is again from I think in your NCERT only. NCERT, electric motor takes 5 ampere. So, next question, I given, always write these breakups. See, I am always writing this. It will be easier for you. 5 ampere from 220 volt line. 220 volt line. And this is electric motor. I am determining the power. Power and energy. So, the great formula of power, P is equal to VI. Find P and energy is equal to, what will be the energy then? Energy is equal to P into T. Because P is equal to E upon T. So, E is equal to P into T. This is how you can find. Very, very easy. I am telling you, electricity numericals are nothing. Only the formulas has to be clear to your mind. Then only it will be easier for you. Yes? Okay. So any of the doubt, or if you want more numerical session, please write it in the comment section. I will definitely go with it. Yes student, I hope you all are liking my videos. Please like it, share it, write comments in it, and so that it will give me confidence. Yes, the students are getting it. And finally, subscribe. Okay, thank you so much student. Thank you 10th class.